Hi, my name is Indrajit. I'm a solutions architect at AWS Singapore. I want to thank you for joining this session, which is all things AI/ML. So let's see what we're going to cover in this session today. We will look at machine learning from software developers' perspective. And then we will walk through two distinct use cases. Now, why I say distinct? Stay tuned for that. We will cover their architecture, discuss key AWS AI/ML services like Recognition, Amazon Personalize, and Sagemaker, and of course, a couple of demos so you can experience it. Now, it is important to understand our mission here, which is to put machine learning in hands of every developer. But to make this happen, we need to understand what developers need. What are their challenges? While we are simplifying machine learning, we do understand developers need an ecosystem. They need developer tools so they can start playing around with machine learning, and then they can integrate ML into their software development lifecycle. Now, talking about SDLC, let's move on to our next slide, which talks about SDLC, which is software development lifecycle, and machine learning lifecycle next to each other. So we can see the differences or similarities, however you want to look at it. If you see, both processes start with business need or a use case. Once that is done, in software development lifecycle, once you understand the requirement, you start writing the code, wherein in machine learning lifecycle, it all starts with identifying your data sources, understanding your data and collecting it. Then you move on to data analysis phase, where you start processing the data, clean the data, perform feature selection, feature engineering, where you handle NaN values, which are missing data, or imbalance features, normalization, category of data. This can be a pipeline by itself. Once this is done, you move on to modeling phase. Now, this is the phase where you choose the right machine learning algorithm for your use case. And this is where you start experiencing the value AWS AI and ML services bring in. Then you deploy the model. You integrate your apps with this model endpoint, which is hosted. You start performing tests. You productionize it. You start its operations, which is very similar to phases in software development lifecycle. Now, you may wonder how AWS can help here, right? Well, that question brings us to this slide. If you remember the first two phases of machine learning lifecycle, which is data collection and data analysis, AWS offers extensive tooling to help you exactly with that. You can see those services in the data analytics section. And the section below represents our AI and ML services, of course, a subset of it. Now, if you think for a while, machine learning lifecycle primarily can be broken into two segments: data analytics and machine learning. Okay? So on that note, let's explore the world of AWS machine learning services. Here you see the most comprehensive tools and services you can find for your AI and ML use cases. At AWS, we see machine learning stack having three key layers. At the bottom are the frameworks and the infrastructure for those comfortable in building and maintaining their own ML platform. In the middle, we have the ML services layer. That is what makes it easy for the ML developers and data scientists to build, train, deploy machine learning models at a click of a button. And that's Amazon Sagemaker. In recent times, we have added many features in Sagemaker with developers in the mind, so to help them build faster and efficiently. Amazon Sagemaker is pre-configured with latest Intel-optimized versions of TensorFlow and MXNet for maximum performance on C5 instances running on Intel Xeon Platinum processors, so developers can quickly train the deep learning models. With one-click deployment feature of Sagemaker, developers can push models to clouds on AWS C5 instances, which are based on Intel Xeon scalable processors, to run advanced compute-heavy workloads, or directly to edge devices using devices like AWS DeepLens, which are running Intel Atom processor and OpenVINO for device inferences. We have other sessions dedicated to Sagemaker. I request you to please check them out if you're interested. In the top layer, we have AI services that allow all developers to use pre-trained and auto-trained models and add intelligence to your applications without machine learning expertise. Now you will notice my first use case is built extensively using AWS AI services. To be more specific, I have used AWS Recognition, which is an image and video analysis service from AWS, and Amazon Personalize, which makes it super easy for developers to create individualized recommendation services. On that note, let's proceed to the use cases. Now, to really justify the title of this session, All Things AI/ML, I have intentionally taken two use cases which are quite different from each other. The first use case is for day-to-day regular user persona, whereas the second one is more focused on enterprise needs, where I will showcase how easy it is to build intelligent apps using only native services. On that note, let's proceed to my use case one. Imagine you're watching a movie or a web series or a daily news, and you really like that jacket that actor is wearing or the bag that actress is carrying. Today, there is practically no easy way to know more about that product. We are still relying on the old methods of showing the advertisers towards the end or towards the beginning or towards when the credits roll. More often than not, it is a missed opportunity for all three parties involved: content provider, the advertiser, and the audience. Now imagine you get the power to choose, and at a click of a button, you get a notification on where to buy that product, either online or in-store. This changes the user experience completely. And that's what my use case number one is. Let's look at the demo. All right, so what I've done is I've created this single-page web application and has an embedded video from our reInvent. We do a lot of fun activities there. So imagine I like this t-shirt and I want to know from where I can buy it. What I do is I take a snap, it's stored on my hard disk, I choose that image which I've taken, I upload it to S3. Now when I click Get Recommendations, that's where magic happens. That's where recommendations will give me this list of where to buy this product from. I right click, I open it, and what I get is an Amazon.com link to buy this t-shirt. Voila, that's my demo. Awesome. So let's break down this solution into our typical three-tier application architecture. We have front end, which is a simple web app, which you saw. It can be a single-page application hosted on S3, presented by CloudFront, which is our CDN service. It can be a mobile app. Then it has a middleware component to it, which is primarily Lambda, in my case. Lambda is our serverless compute offering. This is where the core logic sits. And last but not the least, the two main services which made this solution and use case possible are Amazon Recognition and Personalize. So what happens when you click on that Get Recommendations button? It calls an API, which is hosted on our API Gateway service, which has Lambda integrated into it. As I said, Lambda holds the core logic. This Lambda triggers Recognition's Detect Labels API. When that happens, Detect Labels API extracts metadata from that image which I uploaded. This image is uploaded in S3. Further processing is done on this image. When I say further processing, I capture some metadata, including the apparel, clothing, sports, t-shirt in this case. I assign a particular ASIN value, which acts like an item ID to my personalized recommendations engine. And that's where recommendations happen. All right, now since you have a fair idea of this solution, let's dive deep into Personalize, Amazon's service to build recommendation engines without extensive ML experience. Amazon Personalize, based on technology that powers Amazon. It is a fully managed service generating personalized recommendations. Personalize can be used by all developers and does not need any ML experience. If you look at the diagram, we start by providing three kinds of data sets. User interactions. What are users clicking on? What are they purchasing? What are they watching? This has strongest signal for personalization and is the only data set compulsory. The other two are optional. Inventory, aka catalog, which details about your items, item ID, price, genre, etc. User details, it's about user age, gender, etc. Once you get the data, it is very simple to get a trained personalization model in Personalize. And then, when recommendations using real-time APIs, the entire process above can be completed with 5 API calls. Yes. The model trains are custom to you and are private to you. Now let's understand how I built my recommendations model and this solution. I use Amazon's clothing, shoes, and jewelry dataset from the link given in the slide. Now let's look at the dataset itself. What we have is a raw JSON dataset, which we convert into CSV, and this is our user interactions file, which will go into personalize. Phase 2 is where we create dataset group, and then a solution by selecting appropriate recipe. We have option to choose AutoML, which will choose the best performing recipe automatically. So what is this recipe? It is nothing but a pre-configured algorithm tailored for a specific use case. What are those use cases? We have HRNN, which predicts which item user will interact with next. We have SIMS, which shows similar items. We have ranking and popularity count. It is very important you choose the right recipe as per your use case. In my use case, I selected SIMS, which gives me similar items, like you saw in the demo. And finally, we create a campaign, which is hosting our trained model. Campaign is also created using an ARN, which will be called using AWS SDK or applications or Lambda in my use case. So now let's go back to the architecture diagram to summarize. Finally, let's summarize and revisit the architecture again. It may be easier for you to understand the flow now. In this journey of use case 1, we built a serverless application using AWS AI services. You could see our mission, machine learning in hands of every developer coming true. Because in this entire use case, you never saw me worry about those complex machine learning algorithms, build convolutional neural networks for training images, or anything of that sort. Neither you saw me worry about creating servers, storage, networks. This is the power of serverless application. Now, if you have some specific use case or custom use case, you can always consider Sagemaker, which is apparently core to my second use case. Or you can check out our partner solutions, for example, vSense, who has done some fantastic work in image analysis and visual commerce. Request you to please check them out if needed. Awesome. This sets up good foundation to move on to my second use case, which is powered by Sagemaker. Okay, let's understand the objective of my second use case. We know SAP, right? It is the global leader in enterprise applications and ERP space. AWS and SAP have over a decade experience serving customers together. Now, if you see SAP's vision of intelligent enterprise, it talks about enterprises that use latest technology to turn insight into actions across business. Now, coming back to our mission, machine learning in hands of every developer, and to my title, All Things AI/ML, imagine you're able to integrate our machine learning services, especially Sagemaker, into SAP workloads using only native tools provided by SAP and AWS. And that's my use case 2. So this time, let me not start with the demo first, because it may not be as user-intuitive as the demo in the use case 1. Let's start with the architecture. On the left, you see standard SAP on AWS deployment, which has HANA as a database, NetWeaver as the app layer, and other functional modules, which are running on top of it, can be SD, material management, finance, whatever enterprises like. On the right, you see AWS services, including Sagemaker, Lambda, API Gateway, and other used to connect ABAP layer of SAP to AWS. Okay, let's understand the business problem we are trying to solve here. Imagine an enterprise who is into logistics or supply chain, or any industry which needs to know or plan their inventory items, who has some kind of regression problem in terms of machine learning. In the demo, I take example of a bike rental company who is using SAP as their ERP, who needs to predict the number of bikes to be rented in a particular hour on a particular day so they can plan their inventory accordingly. In this demo, I will pass few features, seasonality, day, time, temperature of my inventory stock from ABAP, and I get predicted stock quantity. Like we saw earlier, first phase of machine learning is data collection and data analysis. For my use case, I perform export tables from SAP to extract the data set and upload it to S3. In the demo, I'm using pre-built machine learning algorithm, XGBoost, in Sagemaker. Sagemaker has many built-in algorithms for many predefined use cases. Amazon Sagemaker platform is based on Docker containers, where every built-in algorithm is a Docker image, prepared with all the necessary libraries, frameworks, binaries, along with the algorithm itself. On this note, let's take a quick look at Sagemaker itself. Amazon Sagemaker, a fully managed service that removes heavy lifting from each step of machine learning process. Since launch, AWS has regularly added new capabilities to Sagemaker, with more than 50 new capabilities delivered over past 12 months. With Sagemaker, you have flexibility to use automated machine learning or use any component as modular capability. Amazon C5 and M5 instances featuring Intel Xeon scalable processors are ideal CPUs for running ML inference. With elastic inference, you can add GPU acceleration wherever needed. This dramatically reduces your overall inference cost. Finally, once the endpoint is ready, we need to create a Lambda function, which will be invoked by API gateway. When we send the post method to the API URL, the post method will pass features in JSON, which will be needed to predict the count. Great, so what I have is an ABAP developer screen. If I go, I type in SE38, which is my ABAP editor. I've written an ABAP code, which you see the name of the program. If I click on change, you'll get to see the ABAP code which I've written. I've created a HTTP client with a destination mm_SageMaker model. This will open up the RFC connection. Let's type SM59 for the transaction code. This will open the RFC connections page. Here I've created an HTTP connections to external server. Let's click on that and see what it is there. If I click on that, I click on edit. What I see now is the target host. This is the API URL which I'm calling in from the screen. Let's go, let's see what this API looks like. This API gateway, this is the beta version of it, and that's the invoke URL which I will be using to pass my predicted values. Let's try to see what this URL looks like. I go into an application called as Resta, which is very similar to Postman. I paste in the URL. I select the method, which is post. I go to body. I change the type to JSON. This is where I will key in the feature sets. Let's copy the feature sets from my screen and let's paste it on the Resta. So let's see how these feature sets are placed in my ABAP code. If I scroll down, I see this instances types, right, which has features. You see the date, time, and other variables. Let's go to this Resta URL, copy it, and let's click on send. Oops, I got an error. Let's go back, change, remove the space, let's send, and that's it. What I get is a body. I return the count, which is 571 for this particular data set. Let's try to play around with this input variables. Let's change, say, the day of the month. Let's change it to, say, 26. Let's change the time to a little bit an off-peak time, say 3 p.m. And let's see how the changes happen. And we see the count decrease to 266, which means it's correct. Let's change it back again to, say, 5 p.m. And let's change the date to, say, 31st of March. And let's see what we see. We see the count increase as expected, 588, considering 5 p.m. is a peak time. Let's go back onto our ABAP code. We can see the feature set there. We have date, time, and other parameters like temperature and things. We execute it by activating it. Once activated, let's execute the code. And we should get the output, which is 571. Let's see how it works. There you go. What you see on the screen is the value 571. If you now compare it with the Resta output, let's change it back to, say, 30th of March and 6 p.m., which is 18 hours. Let's send. We should get 571, which is the value you see on the screen. Let's press send. And there you go. What you have is 571, which is similar to what you got from the ABAP code. So this means now you can always enhance your ABAP code to feed this value into another table as needed, and you can create further reports out of it. But what we successfully did here is integrated two completely separate systems, SAP and Sagemaker, using native services. Great. So that's where I would like to summarize my session, wherein we understood machine learning lifecycle. We went through two interesting use cases using AWS ML and AI services like Sagemaker, Recognition, and Personalize. Again, Going back to our mission, put machine learning in hands of every developer, we built some more tools to make machine learning fun and make developers machine learning developers. As you can see on the screen, we have AWS Deep Lens to run deep learning models locally on the camera, to recognize and classify images, videos without streaming the content back to the cloud. It has Intel CLDNN library that is optimized for MXNet and Intel Deep Learning Deployment Toolkit optimized to train models and accelerate inference of AI computer vision solutions on Intel-powered edge devices. AWS Deep Racer is 1/18th scale race car powered by Intel OpenVINO Toolkit, which gives an exciting and fun way to learn reinforcement learning. One final thought I want you to leave with is, the power of machine learning is in your hands. All you need is imagination. On that note, I want to thank you for joining this session. I hope it was fun. As always, we value your feedback, so please feel free to do so. Thank you.